Hello, today we're looking at fractions, something that terrifies everyone for absolutely no reason. A fraction is just an equal part of a whole number. So people say it's less than one, but we'll come to learn that that's not always the case. So a fraction is just an equal part, and in this case, it is a value that is less than one. Here we've got our fraction. The top number is called the numerator. The bottom number is called the denominator. And the way that I like to remember that is you sit on your denominator. So it is the bottom number. If you remember that you sit on your denominator, the only thing that you need to remember is the numerator, which is the top number. Here we've got our fraction. And the numerator tells us how many parts we've got. And the denominator tells us out of how many in total. So here we've got 2 out of 3. 2 equal parts of the 3 parts we've got. So if we look at what that looks like when we shade, it would be having those 2 boxes shaded 2 parts out of the 3. That's like saying I've had 2 pieces of chocolate from my chocolate bar that had 3 pieces. So that is the equivalent of 2/3. The next step from moving on from fractions, now that we've understood that, is equivalent fractions, okay? Equivalent fractions. That means fractions that are equal to each other. And the word gives us the clue there. It's equal fractions, so they're equivalent of each other. Here I've got 2 fractions. The first one that I want to shade is, let me see. I've got a line missing. If I want to shade half of that, I'm going to shade 1 out of the 2. So here I'm shading half. So if that was a pizza, a rectangular pizza, I would have had 1 piece of pizza out of the 2 that I've got, okay? Now, if I want to find an equivalent fraction, I can look at shading the same amount of the same amount of the 2 shapes. What is the difference between these 2 fractions? Well, I've eaten the same amount of pizza. The difference is I've had 1 big piece of pizza here out of the 2 that I've got. Here, I've had 1, 2, 3, 4 pieces of pizza, but they're smaller. They've been cut into, let me check, how many have I got in total? 1, 2, 3, 4, 5, 6. They've been cut into 8s. So I could either eat 1 out of 2, which would be half of a pizza, or I could eat 4 smaller pieces out of the 8, but that's still the same amount of pizza that I've eaten. I've just eaten it in smaller chunks. In fraction, when we're working with fractions, the denominator, remember the number at the bottom, you sit on your bottom, the denominator. If that number is bigger, then the individual fraction size is smaller. So 1/2 is the same as 4/8. Now, based on that learning, let's look at a different fraction. Let's look at a quarter. All right. Here, I've got, oh my goodness, technical difficulties. Sorry about that. If I was going to have eaten a quarter of this pizza, how many boxes am I going to shade out of the 4 I've got? Remember, what does the numerator tell us? Exactly, I'm going to shade in 1 out of those 4. That is a quarter. I've had 1 piece of pizza out of the 4 pieces I put it into. Wait a second. If I shade in the same amount on this side, I'm going to have eaten the same amount of pizza, but how many pieces have I eaten? How many smaller pieces have I had? 1, 2, 3, 4. So my numerator is going to be 4. How many have I had in total? I can count each individual box, or I can work out by times in the 2. So 4 and 4 is 16. So here I've had 1 quarter, which is 1 larger piece out of the 4 I've cut, and over here I've had 4 smaller pieces out of the 16, but I've still had the same amount of pizza. Those 2 are equivalent, they're equivalent fractions. Let's look at what that means if we want to get rid of the pictorial representation. We need to look at the relationship between the 2 numbers here. What do I do to 4 to get 16? Times by 4. 4 times 4 is 16, squared number. Wait, what I do to the bottom I can do to the top. What's the relationship between 1 and 4? 1 times 4 is 4. So using this method, we can straight away remove the pictorial representation and use our maths knowledge to help. So let's look at another fraction. Let's look at a third. What can I do to a third to make it an equivalent fraction to work out something that is the same fraction? Well, what I do to the bottom, I do to the top. And what I do to the top, I do to the bottom. So if I was going to multiply 1 by 3, the numerator by 3, then I'd need to times the denominator by 3 as well. What's 1 times 3? 3. What's 3 times 3? Squared number again, we did that the other day. 9. So because of my mathematical knowledge, I know that 1/3 equals 3/9 just by doing the same multiplication. What I do to the bottom, I do to the top. What I do to the top, I do to the bottom. If you don't do that and you times it by a different number, your answer will not be equivalent. Just want to show how that could also be applied for the inverse. Quite often you'll see a question where they want you to work out what's going to go here. I've got to use my times table knowledge. What have I done to 12 to get to 4? 4, 8. I did 4 times 3 is 12. So therefore 12 divided by 3 equals 4. Because I've worked out that relationship and what I do to the bottom, I do to the top, I can now work out my missing number. What I do to the bottom, I do to the top. 6 divided by 3. 6 divided by 3. 6 is 2. Therefore, 6/12 is the same as 2/4, which can be simplified to 1/2. They're all a half. They are all equivalent to 1/2 in its simplest form. Hope that helps. Please get in touch if you need some support.